And I'm going to share the screen. Okay, so I'm currently on Epic 3. All right, the model's training. So the next step after the model is trained, right, is we want to print the plot. So this is why here, we did all that coding in the object in the class instance of the classifier, but now we can just easily use these functions. And this is going to become super nice when we're using GANs or transformers, because we need more functionality. All right, so we do plot, we're going to do plot progress, all right, and that's going to help us to plot the loss function. Then we're going to load the test set and just measure performance, basically, all right? So the next step would be we're going to instantiate our class, a second class. So I'm going to do MNIST, and now it's going to be MNIST test data set. All right. Sorry. Oh yes, CNN. Yes. Thank you. CNN, and then here we're just going to load the test set now. So we're going to create a new instance. We're going to call it MNIST data set. And we're just going to load our file, MNIST test.csv. Okay. So once we do that, then we can convert the data in MNIST test. So I'm going to do MNIST underscore test data set dot convert data to tensors, right? So convert data to tensors, okay? And then once it's converted, we're going to select an image and basically classify it. Okay, guys? So I'm going to do output CNN dot forward. And this is inference. This is what I meant. This is the inference. We're not training anymore. We're using a trained model to predict. So here, what do we have to give it? We have to give it some image or a batch of images. So I leave it to you guys, since you guys already know how to do these things, right? To measure performance and all of that. So this is, we need an image. So I'm going to select one image data equal MNIST test data set dot tensor IMGs, and we're just going to pick one of them. So I'm going to pick I'm going to use a variable actually. I'm going to call it record. And I'm just going to say I want record 13. So then that's going to be a record here. Okay. Do you guys see that? All right. And once we have that image, then we're going to plug it into forward and do the prediction. So image data. Now, do we have to do something to image data? Remember, Before you would have an image and spaghettify it. In this example, we have a spaghettified and we have to unspaghettify it because it's a CNN and it expects the data to be in a specific way. So we do view 1, 1, 28 by 28. Got it? And hopefully this should give us our result. Okay. Where's the training? Still, okay, it's almost done with the training. It's got a few iterations left. What else do we want to see? We probably want to see the image, right? So how about we visualize that image? So then how do we do that? Let's do plot image. So we've got this record 13. So we can use MNIST test data set. And we have a function in there called plot image. Plot image. And we plug in record, which is 13. And that's going to return my IMG, comma, label. So we already know how to visualize this. We've done it before. So we're going to do plt dot imshow my IMG plt dot show and print label. Got it? Everyone with me? All right, so where are we on training? Oh, there should be 1, 2, 3, 4, 5, 6. It's got 3 to go. Or 2 to go now. Once we're going to visualize it, obviously, just for one image, and then we have to do what? Have to measure performance, right? So, we're going to run the entire test set. And you can calculate your precision, recall, and so on. So you will have to do this, guys, for the homework, which you know how to do from the SciFAR 10 example, right? We did it for SciFAR 10. So you really should use the SciFAR 10 code and then just add this into it, not the other way around. Okay? Do you guys understand that? Any questions? So you have now the challenge assigned of the competition is going to be in 2 weeks, 2 weeks from today. You all need to present your work and provide a report. And then whoever gets the highest F measure will win the trophy and we'll get an A. Everyone else gets a C minus. But yeah, do your best. Okay. Questions? Huh? Well, because you're gonna get an A, because you're gonna do a great job. As I said, this homework is harder, not super hard, but it's a little bit, tiny bit hard. So start working on it right now. All right, I do think that if you do this, you'll know how to do all of this. Okay. All right, so I'm almost done with this one. So I'm gonna just predict. And that's called the inference part, right? So currently we're training. Once the model's trained, then we can do predictions. Did you guys finish already? Did some of you finish, I'm assuming? So if you have, run these cells and see if the prediction matches what it should on what the image actually is. Hopefully it's gonna finish in a second. All right, so I did 3 epochs. We implemented a CNN. And all right, so it finished. So it took me almost 27 minutes to run this. This is at this point, if I had had a GPU, would have taken a minute or two, right? All right, so let's keep going then. Now we're gonna run the progress. Okay, as you can see, that's the loss function. How do you interpret this loss? It's kind of up and down a little bit, so that's, but it's the darker blue does seem to be at the bottom, which is where you want it, okay? Now I'm gonna load the test set. Okay. Convert the data to tensors. All right, it finished. I'm going to select record 13. We can change that value we want. Now I'm going to select those test samples so I have them. I'm going to plot it just to see what it is. Okay, so it's a 0, right? And the label says that it's a 0. So then what would you want your classifier to do? When it gets this image, it should give you a 0, correct? All right, so let's go ahead and cross our fingers here. So we grab the exact same record, but from in the shape of a tensor, remember, not an image anymore. And we need to unspaghettify it into a 1 by 1 by 28 by 28. Remember, this is the batch, this is the channels, this is the grid. And here we go. Okay, so moment of truth. All right, so let's do output. Should be a tensor. Okay. So this should be a 0. What do you guys think? Correct, right? It's a scientific notation, but you can see it's a -0.1 there. It's the smallest. So it's all right. That's good. We want to kind of view this a little bit better, probably. So what can we do? We can probably do, didn't we have a max function, torch max? Do you guys remember that one? This is a tensor, right? Now that one gave us what? It gave us the value and the index, I think. So then we use torch.max of output. Okay, run that one. Doesn't like it. Val is not defined. Oh yeah, it's an equal. Iteration over a 0 code tensor. Can't remember. Did we have to specify like a dimension or something? I don't remember this function. I believe we used it before. If you guys find it, can you let me know how it works? Yeah, we have to specify the dimensions, so it's dim 1. Okay, try it again. Dimension out of range, expected to be. Okay, expected it to be. Try dimension 0. Otherwise, we're going to have to okay. Yep. And then it would be indexed, correct? And the index is 0. So what do you guys think? That looks like a 0 to me. We can try another one if you guys don't believe in this one. How about 130? So 130 is a what? 6, okay? Let's go ahead and so it should be, this is the smallest, looks promising. And it's a 6. You've got a good model, right? So, you see? Does this make sense? Yeah? All right. Now, you should know how to compute at this point in the class for the whole test set. Okay? So you can run it in batches, however you want to do it. I'm not going to do that part. You guys should be able, but what I need is the F. I would need is the F measure. Now, this is not homework. MNIST is not homework. It's just an example. The homework is Sci-Far 10. Okay, so which is now officially, I've concluded the code, so it is officially assigned. I do want to show you something. So that error that I was getting, not the comma one, but the other one, the way that I fixed it was actually pretty important and I kind of got sidetracked because of the comma error. So if you remember, I was getting an error here because I didn't have that line of code in it. I don't know if you remember. And the reason for that was, if you remember, what view does is it stretches something, it changes the shape, right? But remember, because this is going through, it goes in as a grid, 28 by 28, it goes through the filters, it didn't have the shape of 250. Do you see that? So that's why I had to add the view in there to basically spaghettify, right? I had to take the 28 by 28 by however many things I had, but it's not 784 anymore, it's 250 because the images get shrunk, you know, it's called max pooling. It's part of the layer, doesn't you see that? So that takes us to the last thing I want to show you today, which is whenever you have other images, you will always have to calculate this value. Do you guys see that? That's the one thing that it's not like magically computed for you. You have to know always the shapes of your architectures. So I'm going to show you some code for this part, okay? And then I'll let you guys use that also as part of your homework. Okay. So let's do that one. All right, so I'm gonna put this separate, but it's something that you will have to use it like, you know, in relation to this, okay? All right, so I'm gonna go down here. So we're finished with MNIST. You guys can see that it does predict, and it's a CNN, okay? However, I'm gonna call this figuring out the convolution maths for your model, okay? So I'm gonna just put that heading there. So figuring out. So this is something that initially took me a while to like craft because it's the only way really that you can compute those values. So it's good to have it. So figuring out the convolution maths for your model. Okay. And this is usually for that feed-forward layer right after the convolutional layers. Okay, so we're gonna make this a markdown. Hit run. Okay. All right. So let's do an example. So I'm going to create a torch tensor. I call it my tensor test. And it's going to be torch dot rand n. And I'm going to make it of some strange size. So 1, 3, 30, comma 5, just something. Okay. So this one obviously has batch of 1, 3 channels, RGB, and then it's 30 by 5. Why? I just picked that value. All right, so then you can print out the shape, right? So you should know that. So I'm going to do, I'm going to do my tensor test dot shape. Okay, so just something simple. All right, so we've got 1, 3, 30 by 5. Now you would run a convolution, right? So initialize an object over here. I'm going to call it underscore conv transpose test. Okay, so I'm doing something like that, and I'm going to initialize this as an nn dot conv transpose. Notice I'm using a different kind of a function that doesn't really matter, right? You could use the other one. And so the idea is that you have an input, it's going to go through this convolutional layer, and then it's going to come out on the other side. You want to know, what does the other side look like, right? You don't want to have this mystery of, because it's not easy to like figure it out. But with this approach, this is what I like to use. Okay, so transpose 2D, and then you're going to specify again the things that you need. 3, what is this? The number of channels. Then after that, I want 256. What is that? The number of filters. In the previous example, I only did 10 filters. This is 356 filters. It's way bigger. Okay. But I can do that because I'm not training this. So it's not, it's not going to take forever. It's just one convolution, not tons of convolutions. All right. The kernel size, I'm just picking, some kernel size. Could be 8. Why not? The stride equal to. Okay. All right. I've created my object. Did I make this into? Huh. Why did I do that? All right. Okay. Oh, kernel size. Sorry. Kernel underscore size. Hit run. Okay. And now you are going to run the image through the convolution, right? That's what we want. So I'm going to do then res test. So when you're running the network, you'll probably not want to print out the shape, but you can always build a network separately and kind of figure out the shapes and then use those inside the network. And that's kind of why I'm giving this to you as a separate thing. And so here then we can do, let's say res test. So we're going to take conv transpose test, and this is now a convolution, so it can take an input. So in this case, my tensor test. Do you guys see that? Does this make sense? Oh, that's lowercase t, right? Yep. All right, so if you run this, then basically you're taking an image and running through a convolution and getting an output. That's it. That's, you know, that's the beauty of PyTorch. So go ahead and run it. Okay, so now it's gone through the convolutional layer. And now what we want to do is to print out the shape, right? Kind of makes sense to do that. And so I'm going to do here res test.shape. And there you go. You see that? And that's how you figure it. From there, you totally can figure out the values that you need. Everyone with me? So that's the beauty of this. If you have multiple layers, which you probably would have multiple layers, right? Then you can just keep going and adding other convolutions for the next layer. So then just keep the structure, the logic going. So I would do, let's add another layer with other filters, right? So I'm gonna do here LL. So I'm creating another layer, res test, and this one will be nn.conv transpose, same thing, transpose 2D, but I want it to be another layer. So this one would be 256 by 256. So remember, this one is 256, right? So you want this one to be 256 to match, right? Got it, guys? Which is this 256 right here. And then I want another 256. And I want the kernel size here to be 8 also. Kernel size equal 8 and stride of 2. Okay, so I'm going to run this one. Okay, and now the input to this has to be the output of the previous layer, right? So I'm going to do LL res test. And I'm going to invoke, oh, here, I made a mistake. This is actually LL con, right? To be consistent. So this should be con transpose test. Because the con trans should be the convolutional layers, and then the output of it should be the LL res, as in result, basically. All right, so now I'm going to run this one again. Okay. Copy this one, which is the convolution. And what is the input? Yes, very good. res test is the input. So it's one layer to the next, right? So then we can print out the shape of LL res test. So dot shape. I can't stress enough how important this is. Okay, guys? And you can see again, we've got these shapes. Notice how they keep changing, right? Mysteriously. And that's because it's the product of the convolution that we do. Okay? So it doesn't matter because this is the only thing that matters from convolution to convolution, but it does matter on the last layer. All right, so let's do a third layer. Let's do a third layer. I'm going to call this one SS. So SS con again, transpose test. Be consistent, and it's gonna take in nn dot. So I'm just gonna copy this. So it's gonna take this one Okay, and then con transpose. What should this value be? 256 once again. Okay. Here I'm, for whatever reason, I'm just going to say that I only want 3 filters. I know this might seem confusing and you might think it's 3 classes or 3 channels. It's not. It's 3 filters. Okay. It could be 10, it could be 20, whatever you want it to be. Kernel size is 8, stride is 2. Sometimes you may have a little issue in like a disalignment of the dimensions, right? Especially when you start with strange values like 30 by 5. If you have something like this, I hope you don't, because you'll be doing sci-fi. But if you do have, there's a thing called padding that allows you to pad basically the images so you don't have those kinds of errors, right? So I'm just giving this to you just in case, but I doubt you'll need it, okay? All right, and then we repeat the process again. So I'm gonna run this one. Then I'm gonna run this one here. This is gonna be SS res test. Or res SS. Yeah, res test. And the input to this one should be what? Well, you can see I'm basically building a network kind of in a cell to cell and on the Jupyter notebook. And it's really so that we can print out the shapes and you guys can kind of visualize what's going on. So, which is actually from a mechanical point of view is really important. So we do this one, and as you can see, it is right there. So now what do you want to do? We have a view, right? View was the function that we used. So how would we use view here in the context? We have something like this, right? And then we say what? Because that one was done in the sequential object, if you remember, right? So here we can't just add it after and expect it to work. Oh, I get it now. Okay, yeah. All right, I know how. All right, so let's just do VV view equal to our view object that we can specify a size for it. Okay, a size for it. So in this case, we would have to do this multiplication in order for this to work. So I'm just going to do this first because I know that'll work. 1, 3, 280, 80. Basically, I'm not changing anything, right? I'm just testing that this will work. So then I do that, okay? And then now I'm gonna do VV res, and you invoke VV view, but you can pass something to it as an input. You see that? How nice that is? And so we can do, what would that be? What do we plug in here? What goes here? Right? SS res test, right? All right, great. So if we do that, now VV res equal, shape. So obviously the shape has not changed, but this is where now we have to think of going to the feed forward layer, right? So this part of the code. So I am comparing to our class, I am here now. I've arrived at this. You guys see that? So the logic dictates that we just set the number of channels. We don't care about the batch. And then we just have whatever output we have, right? So then down here, I think we can discard the channels, right? Sorry, the batch size. We should be able to discard the batch size. Yeah. And it really should just be these three values here. So we need to do probably okay, but you should know this value probably. So let me see if that works. Yeah. So in essence, this should be the value that goes in the 250. So this is how you figured out the 250. Guys, do you understand? Does this make sense? Or no? Does it not make sense? Yeah. Well, we can repeat it, right? So this one had 1. We just have to repeat these stride of 5 and 10 and see if we get 250. You see what I'm saying? That's kind of what we have to do. So we did. So the rand value should be what? 1 here. 28 by 28, right? Do you agree? All right. Then this convolution should be what? 1, 10. Can you guys tell me what was the kernel size here? It was 5, I think. The first convolution of the actual architecture. Was it 5?
Yes, 5.
Okay, 5. And the stride was 2, right?
Yes.
All right, so we run that one. Did I leave a 3? Okay. I think it's just I didn't run the first one. All right, so okay, good. So that's what we get actually, a 1 by 10 by 59 by 59. Okay, so now we had a second convolution, correct? What should this value be? 10, very good. And then this one, we had it at 10, correct? What was the kernel size for this layer? 3, I think, correct? And the stride was 2? Okay, go ahead and run it now. Okay, 110 by 119 by 119. And then what else did we have after that? So actually we had the viewer, right? I wonder if these leaky things are. Because it should be 250. But that doesn't give us 250, does it? What's this one? We don't have a second one. Then LL. Yeah, so okay. Well, it wasn't con transpose 2D, so there's that. Let's try what was it? this one, right, guys? It's a different convolution. So yeah, we can just replace it, I think, here. V. And then this one should be 3 instead of 5, right? Oh, and this is 10, right? So 10, 3. Is that correct? You guys see what I'm doing? I just changed the convolution to another one. Let's try this one. Okay, so it changed. And then, okay, liking that. And there you go. Like magic. Math works. All right, so there it is, 250. You guys see? It was a different convolution, so different convolutions will give you different architectures. And that's it. Any questions? You will probably need this for the homework. Make sense? All right, so that concludes the coding part for today. What I'm going to do now is kind of go over some of the intuition. As I said, I had some slides, and I also need you guys to form your groups for the project. Okay, so I'm not hearing any questions, right? I'm going to load up this code to the GitHub because I think it's complete. Let me take a look at it for a second. Yeah, so we did inference, and I'm leaving to you guys to do the actual classification. All right, good. I like this script. So I'll load this one to the GitHub. I'm going to stop the recording right now.